Alright, good morning everyone. Hopefully you're all doing well, or really whatever time you view this video, so it might be good evening. So for this week we can't really do new material as prescribed by the school. Whether or not I follow that, who knows? We're primarily going to be reviewing, working with, verifying tree identities. So what we did all of 2 weeks ago for the Monday, Tuesday, Wednesday, Thursday. We got through section 6.1 all the way to 6.3, if I remember correctly. And then we're going to kind of pick up from there. I'm going to do some stuff with Microsoft Teams. I know some people would prefer posting with pictures. Some people would prefer posting and writing. We're still trying to figure out when to set up Zooms. That way people can actually interact with me and ask me questions live. I still have to figure out how to work with Zoom as well. I know I can record the sessions, but obviously I don't want to go posting videos with students' faces in them, so I'm going to be working on that as well, just because it normally has everyone's picture on the side, so I'd like to avoid having that. Thankfully, I didn't think I'd ever need this again, but I got my drawing tablet from home, so I can actually do live notes in Photoshop, which is awesome. I'm going to get to that in a moment, but that's really the plan is going forward. I'll be using Zoom, or even just like doing a regular YouTube video with no interaction if it's just like a review material to kind of go over different parts of what needs to be done. Zoom will be more of like an actual in-class scenario. I know I put the schedules as hour slots, but it's not going to go longer than the actual time of a class, so it'll never be more than 43 minutes, but it will start promptly. So like if I say we're starting at noon, we're starting at noon, so you should be logged in for noon, ready to go. If you're a little bit late, you're just going to miss the beginning notes. The YouTube videos will be slightly shorter, just because there's going to be a lot of times where I say, hey, take a moment, pause the video, try this on your own, which you should be doing. And then I also don't have to spend time waiting for people to finish taking notes, because if you're still following along to the notes I'm writing, you can just pause the video when I'm done with the problem. So that'll be hopefully nice for people who want to be able to, go back and forth and like rehear things and how they were said, or even just take the time to understand exactly how I went through a problem without needing to be rushed. So hopefully that'll be beneficial for some of you. I'm going to go over the partner assessment at some point. That'll probably be part of tomorrow's video, maybe even Friday's. But overall, they were rough, but they were helpful for me. They were helpful for my EdTPA. So I just want to take this time to really thank everyone. I wrote notes on everyone's assessments. I gave you feedback. It was curved, don't worry. It was designed to be harder. I had to do it in just one day. So we're going to go from there and figure out how to hopefully make this helpful in getting some grades back up. I know there's going to be people who are unhappy with what they got. Nobody got a 0. We're good. But the goal is to try and accommodate the fact that I knew the EdTPA assessment would be harder in order for me to be able to do well on my assessment. So that's going to come into play. I'll make sure that we understand the material from there. That's going to be important, particularly the inverse trig functions, which was on there. So that's going to be in 6.5. We need to be able to take inverse trig functions to be able to solve working with like quadratic trig equations. So that'll be what's coming up. Trying to think if there's anything else, not really that I can think of. So today it's just going to be review. Hopefully you are all feeling well. Hopefully you're not going too crazy yet. Fun fact, this is actually not my first time having to self-isolate. I've done self-isolating for probably a total of 3 months in my life within the past 5 years. So this is actually kind of relaxing for me. It's a lot easier for me, and it was nice to have my break now. That way I can get EdTPA out of the way. So hopefully y'all are staying sane. It's very important to keep a routine going. So like when you wake up, just pretend as if you're still going to school. Like get into the habit of being like, let's do my daily routine. Maybe add like some exercising in, or even some just deep breathing and meditating. But then take the time in your schedule to focus on school in the morning until you would normally leave school. Obviously, it's nice because you can take some breaks. You don't have to worry about running to classes every single time, which is great. And then there's also going to be classes I'm assuming you can't even do. But don't let like not being able to do PE or lessons take away from your schedule. Like, keep those in your schedule. You want to make sure you are staying in a routine. It's great practice for college. It's very important when you get to college to be self-motivated, to have that routine set up for yourself. I personally loved having a time period for naps. Like it was pretty much do my classes until 3 p.m., get home, nap for half an hour, and then go to work. That was my routine. It was helpful. It was keeping me sane, and it was beneficial in getting me through, you know, tougher times where I was like, oh my gosh, I'm exhausted. Let's relax for a little bit. That all said, stay safe. Try and stay away from people. Obviously, that's not always possible if you have to go to a store. Hopefully, everyone's family is doing well. Hopefully, no one's feeling sick. Do everything you can to make sure you're staying healthy. So that requires still going outside, getting some sun. Sun is actually a great way to help kill some germs on your body, just so you know. With that said, let's move on to some of the starting Chapter 6 review. I need my hand. This is going to be... No, I don't know what I just did. Am I still recording? Hold on. Okay, we're good. Whew, I don't know what just happened there. I might not have to use my hotkeys on here, and I just have to stick to... Is it because I pressed the back button? I think it's because I pressed undo. No? I don't know. No idea what happened there. So let's not worry about it then. I forget where my redo button is. That's clear. I need my brush. So this is review for Chapter 6. Primarily what we cared about from chapters, or from section 6.1, were recalling that sine of x is equal to y over the radius. In a unit circle, the radius is just 1, so this is just y. Cosine of x is equal to, I'm going to do something real quick. I'm going to make these thetas. That way we're not confusing ourselves looking at x with cosine in two spots. So this is equal to your x coordinate over your radius. Again, radius is always 1, so this is just equal to x on my hand. And tan of theta is equal to y over our x, which is as simple as it can be. We also have our reciprocal functions. So everything needs a co. So sine does not have co with it, so it's going to be cosecant of theta. Reciprocal, we just change the numerator and denominator. So we would change the y and we would change the r. So we'd have r over y, but the radius is 1, so this is 1 over y. Cosine has the co, so this is just secant of theta is equal to, flip our fraction, so we're going to have radius over x, And this is just 1 over x. And then we also have tan doesn't have co, so it's going to go to co. So this is x over y, which can't be simplified. Now, I'm going to highlight the fact real quick that sine is equal, forgot my theta, 1 over cosecant theta, likewise, this is messy, hold up. Sine theta, likewise cosecant of theta is equal to 1 over sine of theta. These are our reciprocal identities. These are incredibly important. And for 6.1, these are pretty much how we do all of our verifications. Cosine theta is equal to 1 over secant, and then secant of theta is equal to 1 over cosine of theta. I'm going to pause for just a moment before I scroll down. Nope. And lastly, tan of theta is equal to 1 over cotangent. Likewise, cotangent is equal to 1, forgot the theta, 1 over tan of theta. I do have a timer going, so once this gets to like 42 minutes, I'm just going to stop right wherever I am. Our main thing really is going to be using, here's some purple, these. Typically we want to convert everything to sine, cosine, and tangent when working with trig verifications. So, oh my gosh, did this stop recording? I have no idea. I think we're good. So generally we're using these. I'm going to star them. These are super important. So if we remember really that cosecant becomes 1 over sine, or cosecant theta becomes 1 over sine of theta, secant theta goes to 1 over cosine theta, and cotangent goes to 1 over tangent of theta. That's one of the takeaways for 6.1. The next thing we need to take away, we need to go back to default colors. Let's use some blue. In a triangle, I can actually clear all this. Just gonna go draw a triangle real quick. It's gotta be right. That was miserable. I can actually do this perfectly. Undo. If I do shift and go down. Okay. So in a right triangle, we have our theta. We then have our I'm going to make this look correct for a Cartesian coordinate. If I was in the Cartesian plane, this would be my x, this would be my y. We know y is equal to sine of theta, and we know x is equal to cosine of theta. here is my radius. Well, in a unit circle, radius is always equal to 1. It's the definition of a unit. Now, we know we want to apply some theorems we know from the past. So right now we are looking at our Pythagorean identity. Let's do this image color. So the Pythagorean theorem says a squared plus b squared is equal to c squared. In this case, our c is our radius. It's the longest side, it's the hypotenuse in a right triangle. So then our a is going to be our sine squared theta plus b is cosine, so cosine squared theta is equal to r squared. Well, r is just 1 and 1 squared is still 1. So this, I'm going to do this in yellow, is really important for us, really this entire chapter and going forward. So this is the Pythagorean identity. Sine squared of theta plus cosine squared of theta is equal to 1. This is one way to simplify any trig identity that you were given or trig verification you were giving. You want to be able to get things to sine squared of theta plus cosine squared of theta so we can reduce it to 1 because 1 is really simple to work with. We're going to see some examples of this in a moment. For now, I just want to finish other material. I don't think we really have much else. Odds and evens. Okay, the last one we want to worry about. Oh, that's what it was. Before we get to odd and even, the last thing we can do, and this I'm really just going to give you, this is the main one to remember. This is the important one. We can use this to derive other equations. If I were to divide both sides by sine squared, I would get 1 plus, well, cosine over sine. So I'd have cosine squared theta over sine squared theta equals 1 over sine squared theta. So this simplifies to cosine over sine is cotangent. So 1 plus cotangent squared of theta is equal to 1 over sine is cosecant squared theta. I could then go back and let's do this in blue. Divide by cosine squared. So you get sine squared theta over cosine squared theta plus, well, cosine divided by cosine is 1. It's equal to 1 over cosine squared theta. This just gives us tan squared theta plus 1 is equal to secant squared theta. In class, when we did this, we went further and we subtracted cotangent from both sides. So we had 1 minus, let me go to this other color. So we had 1 equals cosecant squared theta minus cotangent squared theta. And then the other one we had 1 is equal to secant squared theta minus tan squared theta. These ones are not particularly as important given that we can derive them using our original sine squared theta plus cosine squared theta equals 1. if you know the 1 plus cotangent squared theta equals cosecant squared theta, and then the tangent squared plus 1, those will be good enough, because then you can just add and subtract as needed to get to a form where you have 1 by itself. Again, our goal is always to be able to get 1 by itself, but if we change things to sine and cosine to start, we should be able to get this form. But if you recognize, oh hey, I have cosecant squared theta minus cotangent squared to start, rather than having to switch it, you could just get 1 from the get-go. Okay, last thing. Oh, I did the wrong thing. I have to deselect this. Let's go back to my default colors, and now I can clear it. Let's move up. Really, I should not be doing this, and I should be saving these notes and just posting them. So I'm going to stop clearing things from now on. Alright, our last identities from 6.1 that we cared about. We know coterminal angles as well. Those aren't, just a refresher, so coterminal angles. If I have sine of theta, well, sine of theta is equal to sine of theta plus 2 pi. So that was super brief with coterminal angles. We also talked about complementary. We know sine complements cosine. So sine of theta is equal to cosine of pi over 2, since it's 90 degrees, minus theta if theta is less than pi over 2. You also need theta greater than 0. So these aren't necessarily as important. We don't really use them within the text. The last one that will be beneficial are odd and evens. So just a refresher, cosine and thus secant are even. So this means cosine of negative theta is just equal to cosine of theta. If I quickly look at a horribly drawn unit circle, if I had, say, pi over 4 and 7 pi over 4, we notice that the x values are both positive. They're both going to be root 2 over 2, which is why it's even. Our odd functions are the other ones. So sine, cosecant, tan, and cotangent are all odd. So sine of negative theta is equal to negative sine of theta. I guess this would actually be called negative pi over 4. So for here, pi over 4 for sine is also root 2 over 2. But then negative pi over 4 is actually negative root 2 over 2. So this is all based on symmetry about the x-axis. Okay. There are 20 minutes left still. Surprising. So with all this in mind, I'm going to zoom out. I'm going to figure out where I want to zoom in. We can now start looking again at solving trig identities and verifying trig identities. Just to practice, we've done some of these before, but if we're looking at, say, tan of x times sine of x, these in parentheses, plus cosine of x. Alright, our first step is really always converting tan. Tan we know is sine x over cosine of x. Now I'm going to write sine as a fraction, so this is sine of x over 1. And I'm going to write cosine as a fraction as well. So times cosine of x over 1. I can multiply through for sine x times sine of x and cosine of x times 1. So I get sine squared of x over cosine of x. And then I would bring down cosine of x plus 1. Sorry, cosine of x over 1. Now, if I recall, if I have 3/4 plus a half, I can't actually add 3/4 and a half yet. I have to get a common denominator. I would multiply both the numerator and denominator by the same number. So in other words, I'm multiplying by 1. In this case, to get to 4, I have to do 2 times 2. So 2 times 2 is 4. 1 times 2 is 2. In this case, 2 over 2 is still 1. So over here, I need to get cosine in the denominator, and I have 1 to start. So I can multiply this by cosine. Let me go erase. I think it's this. No, I don't remember what the code is for doing that. There's a way to sometimes just delete like a circle, and then you could tap inside the circle and delete it. That's what I was trying to do. I don't remember how to do it, so I'm not going to. In this case, cosine over cosine is 1. So cosine x times cosine of x is cosine squared. So I have sine squared x over cosine x plus cosine squared over 1 times cosine of x is cosine of x. Now I have like denominators or common denominators, so I can combine this into one fraction. So I have sine squared x plus cosine squared x all over cosine squared, sorry, not cosine squared, nope, cosine of x. So, well, if we go back to our Pythag identity, sine squared, I'm going to do this in a different color. Oops. So this told us sine squared x plus cosine squared x is just equal to 1. So this is equal to, well, I have sine squared x plus cosine squared x. So this is just 1 over cosine of x. Our reciprocal for cosine is secant. I have 1 over cosine of x, so this is just secant of x. I'm going to pause for a moment, give a moment for people to catch up. Should have time for a few more. Okay, one more quick one for just solving a one-sided identity. or simplifying, I should say. So for simplifying an identity, I want my brush. Let's look at, so this one is the practicing kind of forms, cosecant squared x plus 1 over secant squared x. So we can, remember this technically here is secant x times secant x, which is the same as secant x squared. So I can actually write this, well, cosecant, this is 1 over cosecant x squared. This is plus 1 over secant x squared. Well, 1 squared is just 1, so really this is 1 over cosecant x all squared plus 1 over secant x all squared. 1 over cosecant, well, this is a reciprocal. Cosecant goes with sine, so this is actually sine x squared. Secant goes with cosine. This is a reciprocal because I have 1 over trig function. So this is cosine of x squared. Well, I really can rewrite these now. Erase my 2 there, erase my 2 there. Write it on the inside. So here's sine squared of x, cosine squared of x. And this is just 1 by the Pythagorean identity. Okay, we're going to look at, I'm actually probably going to take the time to show how to upload an image for those of you who would rather upload images. Okay, so looking at, well, this was really still with 6.1 if I remember correctly. So those were simplifying trig identities, or we also want to look at verifying identities. So for verifying identities, we get 2 sides. So over here, I need to switch my brush. We'll have, as an example, sine x plus 1 over sine of x. This is going to be equal to cotangent squared x over 1 minus cosecant x. So to refresh our memory, these can either be true, they can be false, or they can be situational. Situational ones usually depend on what trig function you're looking at. If you're looking at tan, well, sometimes you can't actually have an angle for tangent because tangent gets a divide by 0 error when x is 0. So whenever you have pi over 2, 3 pi over 2, 5 pi over 2, etc. For these, we want to be able to get the left side equal to the right side, which will require us to simplify. Typically one side, sometimes we have to do both. The one I'm doing now will require us to actually do both. So let's start over here on the left first. I'm going to do this in green. So this is, well, I can separate these, can separate the numerator as 2 fractions. So sine x over sine x plus 1 over sine x. Okay. Well, we know sine of x over sine of x is 1. We know 1 over sine is a reciprocal, so this is cosecant x. I can't really do much more now. I'm kind of stuck. So what I'm going to do is switch my color again. So I was a genius and accidentally paused the recording in the middle of doing this problem. To fix it, it should have been a negative cotangent squared x. Otherwise, we wouldn't be able to actually do anything with this. So I'm going to go look now. Again, I'd ended with this, but I'm going to probably cut that out. So cotangent squared x. If we recall Pythagorean identity, let me get the brush. I know it's sine. Oops. I want to do this in black. So it's sine squared x plus cosine squared x equals 1. When we divide by cosine on both sides, we can get this. Sorry, when we divide by sine squared on both sides, we can get this in terms of cotangent. We end up getting 1 plus cotangent squared is equal to cosecant squared x. Then we can subtract the 1 from both sides to get cotangent squared x is equal to cosecant squared x minus 1. Since it's a negative cotangent that we need, we can multiply both sides by negative 1. We get negative cotangent squared x is equal to negative cosecant squared x plus 1. So now I can go plug this. I'm going to end up doing this in red this time. I'm going to plug this guy in up top. So this is equal to 1 minus cosecant squared x over 1 minus cosecant x. I'm going to recall differences of squares. We know if we have a squared minus b squared, this can be simplified to a plus b times a minus b. Well, 1 squared is 1, and cosecant squared is, or cosecant times cosecant x is cosecant squared. So this is a difference of squares. I've got 1 minus, or we'll start with a plus cosecant x times 1 minus cosecant x all over 1 minus cosecant x. So now if we look, well, I've got a 1 minus cosecant x term over a 1 minus cosecant x. So these will cancel. Which just leaves me with, make sure you get the right color. I just chose McDonald's colors. Oops. This is equal to 1 plus cosecant x, which, if we look, is equal to our left. So this is true. So this is an example that I wanted to in class, but we didn't get to it. This just shows that sometimes when working with trig verifications, you have to do something to the left and something to the right. We've done this in other examples in class, but this is a little bit easier of an example to see why we have to work with both sides instead of just one. Now, if I wanted to, I'm going to go save this. I already have it saved, I hope. Let's find out. Probably not. JPEG. Say this is video 1. If you are in Windows and you wanted to, I don't know, say you were typing something up in like Microsoft Word or whatever, and you wanted to just take a screenshot, if you do Windows Shift S, brings up this little tool. You can click and drag over what you wanted to copy and then paste it into like Paint. I could paste it here if I wanted to, and now it's going to be super tiny though. I don't need that. I'm going to close this. Now, if I were to go over to Teams, I'm going to go back to posts. This is where all of our posts are, which is awesome. We got a couple more people doing the assignment. If you haven't already posted a reply to this long message I made a while ago where everyone else is now posting, just make sure you do that. This is why I can't actually see something if you put it in your notebooks. Like I have 2 people still who turned it in, but I can't see whatever you posted. I try to go to it, but I don't have permission to access wherever you posted it. So just take those results and copy and paste them into the post for me. That'd be great. Now, for those of you who want to submit files using the notebook pictures, or taking a picture and just posting it, I'm going to go back. I'm going to go to my video 1 partial notes. I'm going to go click this. I'm going to delete this. The reason being is because I now have a new picture. So if you're in a page, let's say you're Adam, and Adam wanted to post something, you go into his folder, you click maybe his quizzes or handed, wherever it would be. Maybe he wants to put something in his homework, so you go to his homework and you do the same thing. I'm going to do this in my video 1 partial notes. I'm going to go to Insert. I'm going to go to a picture. I'm going to go from File. I'm going to choose a file. I'm already where I need it to be, but normally you need to go to wherever you saved the file. Go in, Insert, and then it posts it right in. And I can personally right-click, and I can save whatever you pick, whatever you post, and then I can view it closer, however I need to. So if you say do some work on paper, you can always just use your camera and then email yourself the file, or even just however you transfer files from your phone to your computer. I just do it with a USB wire usually, and then just paste whatever work you take pictures of into here. I know you all have your calc books at home, or sorry, your pre-calc books at home, so particularly for students who are out, I would suggest doing the homework assignment for 6.1. Let's see where I have that. I'll post the details about that when I find it. I'm not going to waste time too much right now. Wherever I put it, I don't know. So do some of the practice problems in the back for 6.1, particularly for the verifications. Again, you're looking for if they are equal. If they're equal, you know it's true. If they're not equal in the end, you might get, we had one in class where we had 1 equals 0. So if you get something that's like 1 equals 0, well, obviously that's not true. So that would be a false verification. And then there aren't really too many that you're going to get that are just partials. But just make sure you're not working with 2 different trig functions. Again, see if you can get everything within the same identities. So if you have one side in cosine, do whatever you can to try and get the other side in terms of cosine instead of leaving it as secant. That will end the video now officially. Hopefully everyone has a good day. Hopefully everyone can get this at some point, and I'll be posting tomorrow.